In this video, we're going to look at how to calculate a percentage composition by mass. So if you can do percentages in maths, you can do percentages in chemistry just as easily. So when you're asked to do a percentage composition by mass, we are basically looking at the percentage by mass. So if you're looking at a percentage, it's a mass out of 100 of each of the different elements within a compound. So it can be calculated using the relative atomic mass of the compound and using the formula or the molecular mass as the total. So once again, like any other percentage, it's the bit over the whole times 100. In order to calculate a percentage composition by mass, you're going to need the Bible of chemistry, and the Bible of chemistry is the periodic table, and you cannot do any calculations without it. So now what I'd like you to do, if you haven't already got one in front of you, go get yourself a periodic table and you can watch me do these examples. So the first question says, calculate the percentage composition by mass of water. So the first thing we're going to need to do is we're going to need to know the formula mass of water. Now you should all be quite competent now at calculating this. So you'd go 2 times the relative atomic mass of hydrogen, add the relative atomic mass of oxygen, and you should just be able to enter these straight into your calculator to find that it comes out to 18.016. Now, let's find the percentage of hydrogen. Now, to find the percentage of hydrogen, we can see in this formula there are 2 hydrogens. So we're going to use the relative atomic mass of hydrogen times 2 over the whole, which is the relative formula mass of water, times 100. So we go to our periodic table and find that hydrogen is 1.008 times 2 divided by our 18.016 times 100, and it comes out to 11.19%. Now let's do oxygen. So the percentage of oxygen will equal the relative atomic mass of oxygen, and there's only one of them, divided by the formula mass of water times 100. So the bit over the whole times 100. 16, which I got off the periodic table, divided by the formula mass, 18.016 times 100, comes out to 88.81%. Now, how do we know we got it right? We do a little check. It's a percentage. Percentages always add to 100. So we quickly add this up. 11.19 at 88.81 equals 100. Wow, I got it right. Now let's calculate the percentage composition by mass of calcium nitrate. So let's see if we can do this. The first thing we need to know is the relative formula mass of calcium nitrate. So we're going to go to our periodic table, follow our formula and substitute them directly in. So we're going to go to the periodic table and find calcium, which is 40.08, add bracket nitrogen, which is 14.01, add oxygen, which is 16, times it by 3, close the bracket, times it by 2, and this should add up to 164.1. The next part is we're going to find the percentage of calcium, the percentage of nitrogen, and the percentage of oxygen. So we go the percentage of calcium will equal the relative atomic mass of calcium divided by the formula mass of calcium nitrate times 100. So this comes out to calcium is 40.08 divided by 164.1 times 100, and this one comes out to 24.42%. Now let's find the percentage of nitrogen. So we need the relative atomic mass of nitrogen. Now we have to be careful here because nitrogen is in a bracket. So in fact, because it's in the bracket, there are 2 nitrogens, so we go times 2, divided by the formula mass of calcium nitrate times 100, which comes out to 14.01 times 2 over 164.1 times 100. And this comes out to 17.07%. Finally, now let's do the percentage of oxygen. So it's going to be the relative atomic mass of oxygen, but we have to be careful because look at this formula. It's in a bracket. So with 3 oxygens there, but because it's in a bracket, 3 times 2 is 6. So we times it by 6 over the relative formula mass of calcium nitrate times 100. So this comes out to oxygen, which is 16 times 6 over 164.1 times 100. And this comes out to be 58.50%. Our last step is to check, does it add up to 100? So 24 at 17 at 58, and that comes out to 99.99, so that's close enough because of rounding, and it's perfect. So look at our last example. We've been asked to find the percentage composition by mass of water in sodium carbonate .10 H2O. In this particular example, we haven't been asked to find every component, so we're not going to waste our time and do that. We're just going to find the one component, the water. So the first thing we're going to need is our formula mass of sodium carbonate .10 H2O. And what we're going to do is we're going to go to our periodic table, follow our formula and add that up. So we've got sodium, which is 22.99 times 2, add carbon, 12.01, add oxygen, 16 times 3, add 10 times brackets water, 2 times hydrogens, which is 2 times 1.008, add 16. And this comes out to be 286.15. Now the other thing we're going to do is, because we've been asked to find the water, I'm going to find the relative formula mass of water at the same time. So I'm going to go here. Well, 2 times hydrogen is 1.008, add 16, comes out to 18.016. So now I can find the percentage of water in this compound by going the relative formula mass of water, but there are 10 of them, times 10, divided by the relative formula mass of the whole thing, times 100. So this will come out to 18.016 times 10 over 286.15 times 100. And this comes out to 62.96%. Now you need to try some yourself. Go to the OneNote, Chemistry Unit 2, Calculations, Percentage Composition. You'll find lots of examples there for you to work through. Good luck.